So we'll begin by adding data. I'm going to add all of the Davidson County LAS files from the folder that I have them stored in. And I'm going to add them read-only, load the files, and pyramid. Next, I'll add a background image so we can reference locations, and I'll use labels so we can see the names of places. And now I'm going to add a file that was provided for this tutorial, which was in your the tutorial data download. It's a shape file with outlines of water bodies, and it's called Water Bodies 2016.shape. It's in the Enforcing Brake Lines folder. Next, check your project settings. Set a project path to a working folder. And verify the coordinate system. And now just save your file, and I'll call it lesson 60300. Next, we're going to change some labels in the LP360 classification legend. So if you go back to the original specs for this data, you'll see that class 10 was actually going to be used for buffered ground, also known as ignored ground for brake line proximity. We're going to use that in this lesson, and also these class 11 withheld. So we're going to simply edit our symbology to change the names for those classes. Remember that these labels are just that. They're labels for our convenience to be able to make the legend match the way the data has actually been classified, or at least the way the definitions of the classes have been used for the project. I'm going to turn off the orthophoto in the background to help some of the darker points and void areas show up a little bit better. Also, if your map background in LP360 is not white, as mine is, you can change the background color in the map layer properties. If I change the legend to classification and the draw type to tin, we can see the classification of the data a bit more clearly. So you have the orange ground, you have the gray unclassified above ground, and in this data set, recall, water was classified on class 9, and you can clearly see that here. Let's take a moment to look at the water bodies shapefile. First, I've changed it here to a heavy blue outline, so you'll be able to see it on my screen. I just adjusted the line properties. Secondly, I want to open the attribute table, which in LP360 you do by just looking at the feature analyst. It's not exactly the same as the attribute table in ARC, but got similar information. And you can see that there is a field in this shapefile called water type, which indicates whether the polygon is delineating a pond or lake, an island, or a river. If I look down on this from above and I change the display back to points, you can clearly see the water body polygon superimposed in the view. And if I go ahead and rotate that as a 3D view, you can see also clearly that the water body polygon has elevation that is appropriate for the surrounding terrain. Now it's time to actually see what happens when we use brake line enforcement. Access this through the File LAS Layer Properties, and on the Display tab you'll see another tab for brake line enforcement. Select that. We're going to say yes, use brake line enforcement, and it already knows that we have a suitable shapefile loaded into the project. We can see it listed there, the water bodies 2016. And if I notice the type field water, if I open that, I see each of the 3 different types that were designated as attributes in the file, and I can say use, the elevation field is contained in the shape. That's where it knows how to get the Z value. We're going to say we're going to enforce those brake lines into the tin. So when we generate the tin, it's going to consider those brake lines as being valid elevation points. We're going to check this box to perform on-the-fly topology correction. And now this is important, the buffer classes. We're going to say when you generate the tin, I want you to ignore the water points, the ignored ground, and the withheld points. All right, the ignored ground and withheld we didn't really go over, but these have been classified in the LAS dataset. Along the shoreline of the water bodies, we buffer some of the points, some of the ground points out to help just smooth the tin surface in that area. So we're going to ignore those 3 classes. Notice I have this checked on. We'll say apply. And that has just now created a tin ignoring the water class. You can see that those blue points are gone from the tin. We do have some points that are still classified as ground and unclassified in the water area. We'll deal with that later. But at least in this way you can see what the effect is on the tin surface of brake line enforcement. Remember that brake line enforcement is applied to the ground surface. So let's see what our tin looks like if we look only at ground points. I'll turn off the water body polygons for a second. It's a little hard to see the flattening when we're zoomed at this level. So let's zoom into this little section of river here. Notice how that surface is completely flat within the polygon area. If I go back to my properties and turn off brake line enforcement, you see the original facets that we noticed before, and those are the things that we're trying to correct when we do hydro flattening. And again, it might be a little more pronounced if you look at it in elevation view, but remember that at this point we're filtering for ground points only. So we're looking at the bare earth tin, and we're correcting the water surface in the bare earth tin. Brake line enforcement can also be applied to the 3D window. So here I'm going back to the area we were looking at earlier, and I've brought up the viewer properties, clicking on the toolbar in the 3D window, and I have the same option under display to use brake line enforcement. And I'm going to go ahead and set that up exactly the same way that I had, using the class 9, 10, and 11 as being ignored. And I'm going to apply that. And you can see that it automatically changes the view in the 3D window. And then remember, let's see what happens if I look just at the ground surface. And let me color that by elevation, so then now you can see the difference that it makes when you do 3D brake line enforcement. And contrast, let's go back and turn it off again. So at this point you should be able to clearly visualize the effects of hydro flattening, and in fact all we've done so far is to enforce the brake lines visually on the screen in the display using the LP360 tools and filters. We haven't at this point done any alteration whatsoever to the LAS file or any derivative products.